Hello, this is finding a missing angle using trigonometry. This is probably one of the most useful things for trigonometry is finding a missing angle. As you'll see down here in our examples, if we can't just use the triangle sum theorem here because we don't know this angle, we only know one angle. So I'd say that this is, in my opinion, one of the most useful parts of trig. I hope everything is going well, everyone's safe. If you have any questions, please email me um, as I put out these videos for you guys, okay? So, first things first is one of the biggest um, parts of this lesson is understanding what an inverse is. Okay, now remember we use inverses to undo something. Okay, so inverses, for example, if you want to undo -1, right, you're going to add 1 to it. Okay, you're going to add 1 to get 0. When you're, adding, you do as such. When you're, if you want to, so if you want to undo addition, you use subtraction, right? If you want to undo multiplication, you're gonna do division. Okay, now when it comes to undoing the sine or cosine or tangent of something, we talk about inverse sine, inverse cosine, and inverse tangent. Okay, so I'm going to dive a little bit deeper in here. Now, I already filled out this first thing here. This is just a reminder, I've talked about this in class, that this symbol here is a Greek symbol for theta. All it is it's a way to represent a missing angle. Okay. So a lot of the times we'll say sine of theta, cosine of theta. That's just a missing angle we're solving for. Instead of saying x, because a lot of the times we use x for sides, but we can also use x for angles. In our first example, we do down here as well. It's just important you know that this just means a missing angle. I guess it's right here, so we can just kind of highlight that, I guess. Okay, a missing angle. All right, but the really important stuff is down here with inverse sine, inverse cosine, and inverse tangent. Okay, that's what these little -1s represent, is the inverse. So the -1 in exponent equals inverse. Okay, so we're going to follow the same steps that we did when solving for a missing side on page 3 of notes. Okay, so this is very similar to page 3 of notes if you want to take a look back at that video and that lesson. So the first thing we're going to do is we're going to circle the missing angle. That's pretty easy here because it's x, right? It's actually a missing angle. It's not a given angle this time. What information do we have? Well, we don't have the opposite. We have the adjacent and we have the hypotenuse. So this, you'll see, we're actually given both the sides this time. We're not solving for a missing side. Okay? Then we're going to use our, as always, our favorite thing in the world, SOHCAHTOA, to determine what trig function we're going to use. Okay, so SOHCAHTOA. Well, what has to do with an adjacent and a hypotenuse? That's ka, right here. Okay, adjacent hypotenuse. Remember, so stands for sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So I have adjacent and hypotenuse here, so that's why I'm using cosine. So I'm going to use the cosine. Okay, we always take the cosine of the angle, which in this case is x. I don't know what it is. And we can set it equal to the adjacent side over the hypotenuse. Why? Because that's what ka stands for. Okay, so I'm going to set that up plugging in the numbers. Cosine of x equals adjacent, which is 3 in this case, over 12. Okay, over 12. So I put cosine of x, I put it over 1. Remember, we can always put it over 1, and then 3 over 12. I put it over 1 so I could cross multiply. So now I have cosine of x times 12 equals 3 times 1, which is just 3. Okay. Now, you're saying, Miss Cullen, but now we got to divide by 12. We're going to be back to this step. Okay, so this is where it changes. I did this because I want you guys to see this is where it changes. This is not the same way to solve. Okay? Our goal is to get x by itself. Simple as that. Our goal is to get x by itself. So if we cross multiply, isn't going to help, right? Because then we're going to be left with cosine of x, and we get back to step 1. Okay? So this is an important thing to understand. This kind of changes things up. When you find yourself in this situation, you need to say, oh, that's not going to help me. So what can we do? Well, we're going to use the inverse. Okay? We want to undo this cosine so we can get x by itself. Okay? So we're going to actually stop and erase everything and come back to this step. So now we have cosine of x equals 3 over 12. Okay. I want to get x by myself. So that is my goal. So I type down here, so what is our goal? Let's put this in green, right? What is our goal? Our goal is to get, oh, I already have that. Our goal is to get x by itself. So what is going to help, I mean? What is going to help? Doing the inverse of the trig function. And where is that, Miss Cullen? What the heck does that mean? Well, let's take an arrow back to all this up here. Bam! These are our inverses. Those are going to help us. Why? Because an inverse undoes something. So, what does that mean, Miss Cullen? Well, if I multiply by an inverse, for example, let's do an example first. If I have 1 over 2, okay? We're going to do 1 over 2, and I want to undo it. I want to undo it. I don't want 1 over 2, right? I want 1 over 2 to undo 1/2 so I can get x by itself here. Well, what am I going to do? You can multiply by the inverse, right? It actually makes more sense than to divide by 1/2. We can multiply by the inverse here, which would be multiply by 2. And what happens when we do that? Remember this. This is back to algebra. Bam. I'm left with x equals, and I multiply by 2 over on this side, x equals 2. Okay? So times 2, x equals 2. Bam. All right? Same thing here. I want to multiply by the inverse. Okay? So we're going to change this to multiplying by the inverse of the trig function. So I'm going to multiply here by cosine of -1, right? -1. And what I do to one side, I gotta do to the other. So if I multiply this by cosine to the -1, that's the inverse. Bam, guys. Those undo each other. Okay, that's a huge thing. So I'm going to draw a little arrow down and say, these undo each other. Okay? And then what do you do to one side? You got to do to the other. So now I'm left with x equals cosine inverse of 3/12, or times 3/12. Miss Cullen, what? Well, that's when we come here to decimals. Okay, now first things first, make sure you're in degrees. And when you come down here, you will see the inverse cosines. You're going to type that in, and of 3/12. Okay, and you get 75.5. Okay, so you can still type this in, right? Just because it looks funky, we don't discriminate here. All right, x equals 75.5. Okay, come on down to the next example. We're going to follow the same process a little bit faster this time. So I'm circling this angle here. I have the opposite side this time, and I have the hypotenuse right away. So that is sine. Okay, so to solve this, I'm going to take the sine of theta. Okay, sine of theta equals 14 over 20. Why 14 over 20? Because sine is opposite over hypotenuse. Okay, so that's my opposite over my hypotenuse. I'm not going to cross multiply here. What am I going to do to inverse my sine to get theta by itself? I'm trying to find the angle, right? So I want to get that by itself. So what am I going to do? I'm going to do the inverse, and what I do to one side, I got to do to both sides. So when I do that, I have inverse sine of 14 over 20. So I'm going to come type that into Desmos. I'm going to do the inverse sine. So functions, inverse sine of 14 divided by 20. And I get 44.24. 44.4. And that's my answer. Theta equals 44.4. For my last example down here, I'm looking for x. I'm given the opposite side and the adjacent side this side. So what is that? TOA. Opposite, adjacent, that's tangent. So I'm going to take the tangent of x equals my opposite over my adjacent. So equals 23 over 31. Next, you're going to ask yourself how you undo tangent. The only way is the inverse tangent. And what you do to one side, you gotta do to the other. These undo each other, so I'm left with my angle x equals the inverse tangent of 23 over 31. So I come here, I go to functions, inverse tangent of 23 over 31, and I get 36.57. And that is how we find the missing angles.